Hello, you're welcome to Optics. My name is Opak Mark and I'll be taking you throughout this course. Now, optics is a branch of physics that deals with the study of the behaviors and the properties of light, and it also looks at the construction of the instruments that use and detect it. We shall look, in our first lesson, we shall look at the definition of light, we shall look at the rays and the beams, we shall look at reflection of light, we shall look at the laws of reflection, we shall look at deviation of light by a plane mirror. Now let us begin our first lesson with the definition of light. Light is a form of energy that travels in a straight line. Light is represented, or the direction of light can be represented using what we call a ray. So let us also look at the rays and the beams. A ray is the direction taken by light. It's the direction taken by light, and is indicated by a straight line with an arrow on it. So it looks like this, a straight line with an arrow on it. If there is no arrow, then it's just a line, but when you add this arrow, it makes this a ray. So whenever you have a line and an arrow, it makes it a ray. And let us also look at the beams. We say a beam is a collection of light rays. So when you have a number of light rays, it forms a beam. We have different types of beams. Now these types of beams are three. We have what you call the parallel beams. The parallel beam, this is where the rays are parallel. For example, when you look at this, the rays are parallel, as you can see. So this type of beams can be seen where we have such lights, and also where we have light from a distant source. Then you also have what you call the convergent beams. The convergent beam, this is where the rays from different directions converge to a common point. So it will be like that. Different directions, they are then converging at a common point. Here we can see this example mainly when we are using what we call the convex mirror. So the convex lens, when you have a convex lens, we shall see that the rays will be converging at a point. So when we have light behind a convex lens, after passing through it, we see that kind of convergence, and that forms a convergent beam, which looks like this. Then you have what you call the divergent beams. Here we have the rays from a common point moving or scattering to different directions. So it will be like this, from a common point scattering to different directions. Examples of this, we can see this from light from torches and also the car headlights. Let us continue and look at reflection of light. Reflection of light is simply the bouncing of light rays as it strikes a reflecting surface. We have different types of reflection. We have what we call the regular reflection. Here we have the parallel incident beams being reflected parallel as it strikes a reflecting surface. And this reflecting surface must be smooth, a smooth reflecting surface. We see examples of this where we have a plane mirror, or when we have clear water, or where we have any polished surface. So we have the incident, this is the diagrammatic representation of regular reflection. The parallel incident beam is reflected as parallel when it emits a plane reflecting or a smooth surface. We also have what we call the irregular reflection, or what we call the diffuse reflection. In this case, the parallel incident beams are reflected as scattered rays. The rays are scattered different directions. This occurs when we have our surface rough. When the surface, instead of being smooth, it is rough. So, for example, if you look at this is a rough surface. So you have the parallel incident rays. These rays are parallel incident rays. They are reflected as scattered beams. Beams in different, or the beams are reflected at different directions. Examples of this is when the surface is maybe unclear water or iron sheets. Let us continue and look at reflection from a plane mirror. Reflection from a plane mirror. Now let us have this plane mirror here. This is our plane mirror. Now this point here is called the point of incidence, that point O. Then we also have this ray, AO, that's called the incident ray. OB is the reflected ray. And then we have this line, which is a normal to the surface, the reflecting surface. That line ON, it is a line, not a ray. This line here is called the normal line. Then we also have these two angles. The angle I is the angle of incidence, and the angle R is the angle of reflection. Let's continue and look at the laws of reflection. The first law states that the incident ray, the reflected ray, the normal, at the point of incidence, all lie in the same plane. At the point of incidence, all lie in the same plane. And our second law states that the angle of incidence is equal to the angle of reflection. Lastly, let's look at deviation of light by a plane mirror. When you talk of deviation, is simply moving away from the original direction. When we move away from the original direction, if you are moving in this direction, and then as you are moving, then you move away from the direction in which you changed the direction, that is a deviation. So let us look at this deviation in a plane mirror. So we can see that this ray, AO, was moving towards P, but when it met this reflecting surface, which is the plane mirror, it was reflected towards OB, and therefore underwent a deviation. So that kind of deviation, this deviation, because it was moving along OB, then it went to OB, so it deviated. So this angle D is called the angle of deviation. We also have different angles here. For example, we have G. This angle G is called the glancing angle. And we also know that this I and R are equal, because from the laws of reflection, I and R are equal from the laws of reflection. Now, since those two angles are equal, it also implies that the angle AOM1 is equal to the angle BOM. And also, the angle AOM1 is equal to the angle MOP, because they are vertically opposite. So if this is G, then this is G. And also if this is G, then this is G. That's why, since we have said that this angle AOM1 is equal to the angle BOM. So this is G and this is G. And this angle D, which is the angle of deviation, can be got as the angle BOP. Now if you want to get that angle BOP or POB, we shall add the angle POM plus the angle BOM. When we add the two angles, it means that we are going to add the G plus the G, which gives us 2G. So it implies that the deviation of light is given by twice the glancing angle. The deviation of light by a plane mirror is given by twice the glancing angle. Thank you. We shall be continuing from here in our next lesson. Have a good day.